Hello everyone! Welcome to another episode of the Monthly Dev. My name is Ido and I'm from daily.dev, and thank you all for coming. If you don't know the Monthly Dev, so we are doing a series of monthly online events where we bring world-class speakers to teach and inspire us all. We organize these events to create a TED-like platform and to teach about the latest and greatest things about web development, accessibility, backend, cloud, and whatnot. And today we have this incredible and awesome lineup we made for you. We will start with Inian, who will talk about how to balance the developer experience with other concerns like performance and security. Next is Ali from AWS. You probably all know her from Tech Twitter. And she will show us how to create a backend in just a few clicks using Amplify. And lastly, we have Tanner, who is the creator of React Query and other great React libraries that powers daily.dev and that I use in my project. And he will demonstrate the power of React Query and why it's so good and why you should use it in your next project. And before we jump into our first talk for today, you already know the drill. We have some swag to give you. So all you need to do to get this awesome swag is to share the event on social media, add the monthly dev hashtag, and we will pick the 10 most creative shares. And you will get this awesome branded backpack. Just make sure to keep your DMs open so we can contact you through Twitter or through LinkedIn, Facebook, or whatever you prefer to share this event. So again, just share on social media with the hashtag and make sure to link to our YouTube stream. So without further ado, let's go immediately to our first speaker for today. Inian is a software engineer at Supabase, an open source alternative to Firebase. And as I mentioned, he's going to show us how to balance developer experience with concerns like performance and security. So please welcome on stage, Inian. Hey.
Hey everyone.
How are you doing?
Doing good. Excited to be here.
Yeah, we are so excited to host you as well. Thank you for coming and doing this talk in such a late hour. So are you ready to start?
Yeah, let's do it.
So if you can just share your screen and we can roll. Okay, perfect. So good luck, and yeah, let's do it.
Okay, cool. So yeah, today I'll be talking about how to balance security, performance, and developer experience, and how we balanced these three aspects while building Supabase storage. And just an hour ago, we announced that Supabase storage is moving from alpha to beta as part of Supabase launch week. This is the week where we launch one new feature for every day of the week. And yesterday we had community day. Today was about storage. And yeah, you can follow Supabase on Twitter at Supabase if you want to follow along. And yeah, but today we'll be talking about Supabase storage. As Ido mentioned, I am a software engineer at Supabase. I generally like performance, accessibility, and security. And you can follow me on Twitter at everconfusedguy. Okay, so before we jump into how we built Supabase storage itself, a bit of introduction into what Supabase is. Supabase is the open source Firebase alternative. So if you have already used Firebase, you are probably aware of the main features that Supabase offers as well. But yeah, for the main differentiators with Supabase is that it's open source. And the other key differentiator with Firebase is that you get a full-fledged SQL database, Postgres under the hood. And project that you spin up with Supabase, you get this real-time built on top of Postgres. You'd get these real-time capabilities. We also have authentication. So whether you're building a website or a mobile app, you can implement authentication for your app with just a few lines of code. I think we already support more than 10 OAuth providers like Google, Twitter, Facebook, GitHub, and so on. And we are announcing a few more updates to our authentication system tomorrow in our launch week. And today I'll be talking about storage, and we are working on functions which will be released soon as well. So what is Supabase storage? So Supabase storage is an object storage service. Anything that's too big to be directly stored in your database, like your images, videos, or like a massive JSON file, those files which are probably not a good idea to be stored in your database, storing it in something like an object storage service would be better. I think it's just easier to just show you a demo of how storage works. And yeah, then we'll go a bit more into some of the design decisions that went into building this. So this is the storage explorer that you see when you come into Supabase. And of course, you can create new buckets when you come into the system, and you can create new folders. And as you would expect, you can upload new objects into the folders as well. The main decisions that we had to make here was that we wanted to build a user interface that felt very intuitive. So if you have used any file explorer in your operating system like Windows or Mac, this sort of navigation would be very familiar to you. And so here I've just stored the GitHub repo for storage itself in storage, because why not? But yeah, that's the main thing that we thought about while building the front end of Supabase storage, is how to make it very similar to a file explorer. There are other challenges that we had as well, because the actual objects in Supabase storage are stored in S3, and S3 is the object storage service by AWS. And S3 doesn't really have a concept of folders, for example, but that is something that you would expect when you are building a object storage service. So for example, if you create a folder here, this folder is actually not persisted in the backend. So if someone reloads the page, sometimes the folder, not sometimes, like before we fixed it, the folder will actually disappear because S3 doesn't have the concept of empty folders, basically. So we had to work around a lot of these issues to make sure that it's a very seamless experience to the user, and to make sure that the user feels that this is just like using File Explorer in your operating system. So that meant adding context menus, supporting operations like adding new folders, like even operations like rename is not an operation that S3 supports, but we had to build that in to make sure that it's a very easy to use experience. So that's basically it on what storage does from a front end perspective. Let's go back into the slides to yeah. So yeah, to start off with, like, why did we build our own object storage service? There are a lot of open source alternatives like Ceph, Swift, Minio, Zenko, which are also object storage service, but none of them fit our use case perfectly. The main reason for this is that none of them integrated with Postgres. So as I mentioned before, each Supabase project comes with a full-fledged Postgres database. And with all of these systems like Ceph or Minio, you need to have another database running to store your object metadata. So for example, to run Minio in a multi-tenant mode, you need etcd running. Similar with Zenko, you need MongoDB or Kafka running, which are not trivial to run at scale. So our main reasoning for building our own auth system or storage service was that we wanted to build something that uses Postgres as the object meta store. And there is also another big challenge when building, evaluating existing systems, was that they came with their own authentication systems as well. But Supabase already has an authentication system, as I mentioned before, and there was no easy way to map, say, Minio users with Supabase users. And we wanted something that's more tightly integrated. And frankly, a lot of these systems also came with features that we didn't really need. Um, when we started building Supabase storage, we realized that most of our customers are going to be users who are using Supabase in the hosted platform, and Supabase itself is on the cloud. And even if a user is self-hosting Supabase, they are probably doing it in a cloud environment, which meant that a lot of features that these other middlewares provide, like bitrot protection, or how do you make use of new storage space when a new disk is plugged into your storage cluster. Like, these are features that we don't need. And since Supabase provides like a very generous free tier, we also wanted to make sure that every service that we run is as optimal as possible, has a very small footprint, so that we can continue to give a good amount of functionality for even our free tier users. So that's basically the reason why we decided to build our own object storage service. And yeah, so the other important thing is, since we store object metadata inside the user's own Postgres database, it makes a lot of things very simple. This is quite a bit of a unappreciated feature when using Supabase storage, is that all the object metadata, in terms of like the object ID, the name of the file, who uploaded it, what time it was uploaded, the size of the file, the content type, all these metadata is stored in your own database. So for it enables a lot of different features and use cases for you. For example, if you want to find out all the files that were more than 10 MB uploaded by this particular user from 1st of Jan to 7th of Jan, it's just a simple SQL query for you. And once you get the list of objects, you can use the API to actually get those objects from Supabase storage, right? I actually don't know if there is an easy way to do this with, say, AWS S3. And by storing all this object metadata in your Postgres database itself, all these kinds of queries become simpler. It's the same thing with the auth system as well. All the authentication metadata is also stored in your own database. And the other cool thing about having the entire metadata in your system is that the users can fine-tune the database to their own workloads. For example, the user can probably add a separate index to the objects table, which make it faster for his particular use case. But this also comes with some challenges. For example, since the user has full control over his own database, they can tamper with the tables. They can probably change the name of the column, which might lead to incorrect behavior, or even can break upgrades. So this is a challenge that we are trying to balance, where we are trying to balance the fact that, okay, we want to give full control over the database to users, but at the same time we want to make sure that the functionality doesn't break, or like when you try to upgrade the storage from one version to the next, the upgrades go smoothly. So the current balance that we have reached is that we actually don't show these tables in our Supabase dashboard, but if the developer connects to the database via an SQL client like pgadmin or table plus or whatever, we assume that the developer knows what they are doing, and they can modify the schema if they want to. So that's on the metadata part of it. The other cool thing that we have built with storage is our authorization system. So as I mentioned before, we already have an authentication system called built with an open source software called GoTrue. This was initially forked from the Netlify's go-through version, and now Supabase also uses go-through for authentication of its users. So at the very crux of it, it's pretty simple. Any user who signs in with a valid credential, he gets a JSON web token back, and the user can log in and conduct further API calls using the JSON web token. And we saw how other systems define authorization rules. So in Firebase, for example, if you want a user to have access to a particular folder, you need to learn this particular syntax, and this is how you define your security rules in Firebase. And if you have been unfortunate enough to write S3 policies in AWS, it looks something like this. And yeah, it's very hard to debug. It's an entirely separate syntax and language. And we wanted to see if we can do something better when defining authorization rules for storage. So yeah, the main insight was to see if we can use SQL itself to define these authorization rules. And yeah, this is how we made that work. So the final missing piece in how we designed our system for authorization and storage is Postgres row level security. So if you haven't used row level security before, it's a pretty cool system where you are able to define policies for your tables. So for example, this row level security policies states that for users should be able to select only if their own ID matches the ID of the user. So even if, say, a user comes with ID 1 and he tries to do select star from users, the Postgres itself returns only one of the rows from the table. The other rows are hidden because the other rows do not pass this policy that is being attached to the table for this particular user. So you don't even need to write, say, for example, select star from users where ID equal to 1. That sort of is taken care of by the row level security policy attached to the users table. So yeah, now that all the building blocks are there, how we designed our authorization system is by simply saying that, okay, the storage middleware assumes the role of the user and tries to say if the user is trying to upload a new object to a bucket, the storage middleware tries to insert a row in the objects table as that user. So if the user is able to insert a new row, they can upload an object to the S3 bucket. And the same for the other CRUD operations, right? So if the user is able to delete a row from the objects table, they can delete an object from the S3 bucket. So the few advantages of doing this, as I said, it's just SQL, which means that you're not limited by the syntax. You can run any SQL function, inbuilt Postgres functions. Supabase comes with like nearly 30 extensions to Postgres, so you can use any function from the extension schema. And we also have like a lot of helper functions to help you write these policies. So as I said, yeah, this is how it works. If a user tries to list objects in a particular folder, the storage middleware assumes the role of the user using the JWT, tries to execute a query on the database as that user. If the query passes through, it actually retrieves the objects from S3 and passes it on. And yeah, this is probably a good time to show you the new policy editor that we have. So all this can be pretty daunting if you haven't used row-level security policies before. So to make it easier for new users to start writing these policies, we have built a quick start template where if you know what you're doing, you can probably start from scratch. If you want some guided help, what we do is that we have a lot of these quick start templates with the most common use cases. where you can quickly start, say, for example, you want to give users access to a folder only if they are logged in. So you can use this template, and you can select which operations should be allowed for that particular user. So for example, if you select insert, the UI shows that the user will be able to call these API methods. So if a user is able to insert into the database, they can copy object, create object, and get assigned URL for the object. So you click review, you see the final SQL that's going to be executed on your database, and you can save the policy into the bucket. So yeah, that's how the new policy editor works. It lets you create new row-level security policies for your storage pretty easily. The second thing that we did was to make sure that we wanted to keep the storage backend as flexible as possible. So right now we use S3 to actually store these objects, but turns out developers usually have very strong opinions on where objects should be stored. When we started GitHub discussion to ask like what are the backends you would like to see, people replied everything from like Google Cloud Storage to Backblaze, Wasabi, and even IPFS. So to support these kind of use cases, what we did was we initially targeted the S3 API, which has sort of become like the industry standard for object storage services. So a lot of these other tools also support the S3 API, so it makes it easy to extend our system to more backends. And we have also intentionally kept the API surface area super small. So even if, say, you have a custom backend that doesn't support the S3 API, as long as you can implement these 6 API calls, you can you can store objects using Supabase storage into that backend. So that was the initial reason why we built the system in such a way, but we actually found a very different use case for it. And that was to enable Supabase storage in the self-hosting setup. So for the self-hosting setup, we have basically a node module where you can install Supabase and just do Supabase up, and you get a fully contained environment with all our services running, the Postgres database, the real-time engine, the auth service, and so on. And it took us some time to get storage into the setup, because till recently, storage had a hard requirement on having an S3 bucket. So if you wanted to run Supabase locally, you need to go create an AWS account, create an IAM user. If you don't know what an IAM user is, sorry, that's another thing you have to learn before you set up Supabase, which was not a good experience. So what we did to enable Supabase for local hosting was that we implemented a new storage backend which uses just the local file system. And I think I even have the code somewhere here, but it's basically implementing those same APIs. But instead of writing it to S3, it just writes it to a local file system. As you can see, it's just using the node APIs to write to a file on your local disk. So that makes it easy to test out Supabase locally. You don't need external service to store your objects, and it's pretty simple to test all your changes locally. And if you want to actually deploy your application, you can use either hosted Supabase or your own S3 bucket. So another thing we had to balance was, again, convenience and security. And enabling public buckets was one key feature where we were super careful with. So any bucket that you create with Supabase is not public by default. We have seen hundreds of horror stories where some AWS S3 bucket is unintentionally public, or some objects are public and people aren't aware of that. and data is exfiltrated from the company because of an exposed S3 bucket, right? So what we decided to do was that instead of allowing certain objects to be public, we only allow entire buckets to be public. So this makes it super clear if a bucket is public or not. So if you go here and you make this bucket public, you know that all the objects here can be accessed without authorization token, and that makes it easier to reason about the permissions required to access objects. So for public buckets, you still need the right row level security policies to upload and delete objects, but you don't need any permissions to view the object. So we made a few more changes to the storage system. I'll probably quickly go through them. But yeah, one of the main things that we launched is that you are able to you can properly stream videos and audio files now because of the way we handle the content type, not content type, content range header. So you can host your cat videos and pictures on Supabase storage. And we also allow you to upload entire directories directly to the storage system. So this lets you say upload the GitHub repository as I showed you before. And we use a non-standard API called the file and directory entries API. This seems to be the only way how you can achieve that, but I didn't find any incompatibilities when we were implementing this. But yeah, before I wrap up, the final thing I wanted to mention was that we paid a lot of attention to the bundle size of Supabase client libraries. So the entire client library for Supabase is under 16 KB, and this involved a lot of decision behind the scenes to figure out like which polyfills to include within the library. For example, our initial storage system was dependent on the form data API, which was not available in Node.js. So it would have been pretty simple for us to just add the polyfill for form data and call it a day. But we decided to support binary uploads in storage directly so that you would be able to upload objects from Node.js without, and that led us, that made the library compatible with Node.js without increasing the bundle size. So yeah, that's about it. You can, the code is completely open source as with anything that we build. You can follow me on Twitter at EverConfusedGuy and follow Supabase at Supabase. Yeah, if there are any questions. Yeah.
Hey, actually, there is one question that I saw. I can help you out because there is a lot of chatter. So yeah, the question is, can you set the content type of the objects?
Yeah. So when you're uploading, you can set the content type explicitly, or if you're using form data to upload, we also try to guess the content type from the data that you're uploading on the server side, but you can explicitly mention it as well.
Perfect. Yeah, I think there were no more questions. Just a question from our side. Can you share a little bit about the future plans of Supabase?
Yeah, so we have a lot planned even just for this week. So as I mentioned, we are releasing new stuff for authentication. We are making a big update to the dashboard that you just saw. And we are also working on Supabase functions, as I mentioned before. So yeah, we are shipping a lot. Follow us to keep updated on. If you have any feature requests, we just launched a Discord channel. So drop by, say hi, and if you want to contribute anything to the Supabase libraries, hit me up and let's discuss.
Yeah, here is one last question. Does Supabase have a free plan?
Yeah, we actually have a pretty generous free plan. You get a full-blown database storage, 10,000 authentication users when you sign up to Supabase. So yeah, you can check out our pricing at supabase.io/pricing. But yeah, we have a pretty generous free plan.
And I think you also didn't mention that Supabase is an open source project, right?
Exactly. So if you want to, you can host it yourself directly on your own cloud provider. And yeah, it's completely open source.
Perfect. So anything last you want to add?
No, that's it. Yeah, you can check our GitHub. We just launched a Discord channel, as I mentioned. So come hang out with us. And yeah, thank you for having me.
So thank you very much for coming and enjoy the rest of your night.
Yeah, thanks. Yeah.
Bye-bye. Before we go into our second talk for today, I just want to let you know about daily.dev, our platform and community. So we built daily.dev as an open source project. It's a one place where you get all the developer news that you need and want. A browser extension. We also have a web application. We just recently released an Android application that you can download now on the Google Play. And basically, if you find yourself navigating between all these blogs, web dev, dev.to, Hackernoon, whatever, instead of navigating through endless blogs, you can just download daily.dev, and we will give you all the blogs and all the articles in one place, so do try us out. And upcoming next is Ali, one of the most famous personas on tech Twitter and in the developers community in general. She's going to show us how you can create backend in just a few clicks using AWS Amplify. So show your love to Ali.
Hey, well, thank you for that introduction. I don't know about all that, but thanks again. I will go ahead and share my screen and go into presenter view.
Let's do it. Okay, perfect. Here is your screen. And yeah, good luck.
Awesome. Thank you so much. I'd love to see your questions in the chat as I go through this too. Those are my favorite part of giving talks. So today I'm going to be talking about the AWS Amplify Admin UI, which launched last year at reInvent. So we're almost at that year mark, and it allows you to do backend web development essentially in clicks. I am Ali. I am a senior developer advocate. I'm lead and manage the Amplify Developer Advocacy team. You can find me at A Spittel pretty much everywhere on the internet except for YouTube, where I'm alispittel.dev. I get to work on the product team that works on this admin UI, so I get to work with it pretty much all day, every day, and I feel very lucky to be able to do so. So our goals for this talk are to first build a fun application to discuss the underlying AWS services that go on under the hood, and then also talk a little bit about Amplify. So what we'll do is we'll create an app backend. We'll test it out locally. For this step, if you don't have an AWS account, that's totally fine. You don't need to worry about entering a credit card or anything like that. You can test it all out locally on your computer first before deploying anything. Then we'll go through the deployment process and manage. We'll use the admin UI to manage your data and add authentication. The last thing that we'll do is we'll actually extend this using the Amplify command line interface. It is important to note that all of this is backwards and forwards compatible. So if you use the admin UI, you can extend it with the CLI and vice versa. So Amplify is a set of AWS tools for front-end and mobile developers specifically. So there's a lot of AWS services that go on behind the scenes that power it, but it makes it a little bit easier for somebody like me, who's mostly a JavaScript developer, to use those services and not have to know a ton about the cloud. So we started with the Amplify command line interface, and that allows you to provision these services using the command line. But for a lot of developers, we wanted to make this even more user-friendly, and we did this lower code kind of solution. Low code is a weird term because I'm not sure if it means the same thing to other people, but we'll talk about that in a minute. So full stack web development is evolving even with my own career. Originally, there was static web pages, and then people started making those a little bit more dynamic with things like PHP and Cold Fusion. And then web frameworks came out, and we used tools like Ruby on Rails and Django to build these full stack applications. That's when I started my career. And there was this 2005 Ruby on Rails demo, if you remember that allowed you to build a blog in 15 minutes with just a couple command line commands. And you can go see that on YouTube and see a little bit of web history if you want. But this is the progression of these types of tooling. And you can generate so much using this kind of scaffolding where you run a command and then a bunch of code is generated underneath the hood. So Next.js does this, Create React app does this, Django does this when you create a new app. And even more recently, there's been this era of serverless and Jamstack, which makes the deployment process a lot easier as well. So tools like AWS Lambda, which is a tool that I have a ton of fun with, there's no more battling with all that server stuff. And so I think of it as this evolution, and maybe low code development is next, but I think that's a really scary term for a lot of developers because it's like, is my job going to go away? Are people not going to need to code anymore? And the answer is, I don't think so. We're always going to be developing the tools that go into that low code development. And no code is already a thing that people are using, like Squarespace or whatever, and that has not taken our jobs yet. That being said, I think there's a lot of power in making it so that we're just doing the hard things. We're not having to reinvent the wheel over and over again. And we've already seen that we can use something like Ruby and Rails to generate a bunch of our code for us. Maybe using a visual interface instead of a command line to generate all that code could be next. And so when I think of low code, I think the tools with the most power and that are the most exciting are the ones that allow you to do just that. You use a visual interface that can make it so that somebody less technical can use it. But then we meet developers where they're at, where they can still write custom code and extend this in any way that they want. So instead of having hundreds of lines of code to do something, you can generate that code and do the same thing in 1 or 2 lines of code. So maybe the less code, the better. Code is really expensive. Hiring developers early on in the life of a startup leads to a very high cost, and it leads to making it so that you need to maintain that code, you need to fix bugs, and you need to have this extensibility and customizability and developer experience, because those things are going to make it so that you can keep building and scaling. So we want to do more to empower developers to do more with less code and to be able to develop in the easiest way possible, leaving time for you to implement your own business logic rather than reinventing something that's already been done before, such as an authentication system or static file storage. Those are things that have been done before, and you don't need to restart from scratch on every single application. So I think the power in developer first low code is that it's almost an extension of the triumphs of the framework and the serverless eras of development. So we want to empower developers to do more with less code and to be able to develop in the easiest way possible. And this Amplify Admin UI that we're going to be playing with, remember, it's not a flimsy toy behind the scenes. It's the same AWS services that people have been using for years and years. So if you want to follow along live, I'm going to be doing some demos. I did everything via video, so we don't have any demo gremlins. Those always come out whenever you're doing live video. But if you want to follow along live, the link for this is admin UI at sandbox.amplifyapp.com. So you can go to that if you want to follow along. So first step is going to be to create our data. We're going to create a database schema using a visual interface. So here you are at that sandbox.amplifyapp.com, and then you can click Get Started to create an app backend. From there, you can pick a feature to set up. So I'll go with data. And then you can add your model. So for this example, we'll do a blank schema, but you could start with a blog instead. So we'll create a video course platform. So I'll start with a course model, and it'll have title and description. And then we'll have videos that belong to those courses. The videos will have titles, descriptions, and an order. And you can change the different field types. So this one will be integer instead of a string. You can also make certain fields required or array types if you need as well. So I'm clicking on those fields and making them required. Then we want to add relationships. So each video is going to, or each course is going to have multiple videos, like any other video course. And so we can create a one-to-many relationship. We can also do one-to-one or many-to-many as well. So then you can click test in your app and test locally, and you can choose between these different types of applications. For example, iOS, web, Android, or you can choose a different framework. So React app, which is I'm doing right here. I just created a React app, and we can skip over the rest of the installation steps, but there's just a couple commands to copy and paste so that you have both Amplify installed and the libraries that'll allow you to connect your backend and your front end. So let's talk about some of the technologies being used under the hood here. So Data Store provides a programming model for both online and offline data. So this data by default is going to be available to users on their local device and synced across users in a cloud database. So that's really nice that you don't need to implement that yourself using something like local storage or session storage or anything like that. It's done for you. Most web apps, I would say, have some sort of offline data that they need to have at this point, especially for mobile apps. AWS AppSync is a managed GraphQL API service that's being provisioned under the hood as well. DynamoDB is the database being used for this. So it's a serverless key value document database that's highly scalable. Like Amazon.com uses it. So it's one of those ones that's pretty well used within the industry. So we've talked a little bit about the technologies under the hood for data. Now let's test our backend locally in our app. And again, I'm doing all of this without even having an AWS account or anything like that. It's all offline for now. So remember in that last step, I ran create React app and then pulled my Amplify app locally. So I can clear out some of the things in that app.js that's provisioned for me by create React app. And then I'm going to make it so that on click, you add a new course. I call this part copy and paste driven development because it generates the code snippets for you and you can just put them in your code. So importing data store, and then it's showing you how to save a new course or create a new course. So then you can change the title to be actually the title of something in a form. I use window.prompt a lot for demos just because it's a little bit shorter than writing out a full React form, but it will now ask us for a title. So get started with React, for example, and then a description of that course. And then we can also fetch the data on page load. So I'm just creating a use effect. Again, standard React code. If you're interested in learning React, by the way, if this looks new to you, I have a bunch of YouTube videos on my YouTube channel about getting started with React. Also have videos where I dive deeper into all the types of code that go into this. So I'm creating this function pull data, which is an asynchronous function, and then I'm making it so that it's going to query for all of my courses. So again, I'm doing that copy and paste driven development, and now you can see that my different courses pop up. They're actually stored offline first, so they are stored in IndexedDB in your browser and local storage on your mobile devices. So right now, it's not being synced to the cloud because we haven't deployed it yet, but once it's deployed, it will sync to that cloud DynamoDB database. So there's like no chances of getting feed for this or anything like that. You're not even logged into AWS. So the next step is to actually deploy it, and that will make it so that you can put your app out into the world. If you just wanted offline data, you could deploy this as is, but you'll most likely want to deploy this so that the data is synced between users. So how we deploy this is we go back to this admin UI. At any point, you can go back to that model tab. If you want to change your schema, you can go back to that, change a field name, add another model, anything like that. You could just run Amplify pull in order to pull that locally. It fulfills this like Git-like model of Amplify push to push something to the cloud, Amplify pull to pull it down. At this point, you do need to log into your AWS account or create one. And then you'll create an app name and choose a deployment region, usually just the one that's closest to you is what I recommend people use. So if this was a larger app though, you'd probably want to think about where your users are. Then it's going to deploy. That takes a couple minutes. I use the magic of video editing to chop a few of those out. And then you can look at your data model once it deploys. You can also make changes live in this console right here. You can also manage your application content. So you can create a new course using this form, so you don't need to create those forms initially within your own app. I've noticed this as a software engineer, which was what I did before I was a developer advocate. A lot of times you would build the internal app and the external app, the internal one for content managers to work with, and then the external ones for end users. So this has a markdown editor and all that. So you could use this for those non-technical users to update data. You can run Amplify pull whenever you change anything on the cloud. That will pull those changes locally. And again, Amplify push to push anything up into the cloud that you do locally. It may ask you a couple questions when you do that Amplify pull again. So another thing that you can do is you can give access to this admin UI to people without the AWS account. So you only need one AWS account to have this all deployed. And so you can go in and give access to people through email. You can either give them full access so that they can update these data models and things themselves, or you can make it so that they only have access to manage the content. So if you only want them to be able to add new blog posts, but not to be able to rename blogs to posts or something like that, then you can do that as well. So that was managing in your app. And then you can also add authentication. So if you go back to this admin UI, you can click Enable Authentication. You can change the login mechanism. So you can do Google, Facebook, Amazon, phone number, login. A sign-in with Apple is coming up too. So you can see that as an option as well. And then you can choose different sign-in attributes. You can make it so that multi-factor authentication is required. You can make it so that people need to use a super secure password or something along those lines. Once you deploy that, you rerun Amplify pull to get the authentication in your app. Then you can install the Amplify React components. And then the with authenticator component will pretty much create your whole login and sign up system for you. So I'm going to import that, use it as a higher order component over my app component, and it'll make it so that you need to sign in or to create an account in order to use the app. You can also create user groups. So if you want to have an admin group or something along those lines, or create a user directly within this console, you can do that as well. So what's going on beneath the hood here is Amazon Cognito, which allows you to add that user sign up, sign in, and access control. You can also enable this two-factor and social authentication. So I also talked about the command line interface. We've seen that a little bit with the Amplify pull, Amplify push, but you can also use this to enable other Amplify categories. So Amplify also allows you to have S3 storage, Lambda functions. It also allows you to have like AI ML and push notifications and things like that. So you can add all of those using the command line interface. I currently haven't. So what you can do here is you can have your app built out, and I cheated and added a little bit more code to display things in between these demos, but you can create a new form, make it so that people have to upload a video so that it's a video course platform. And then we can import that video form into our app component. Also pass the course ID so that we can link those videos up to courses. If you remember, we have the related data, so each course has multiple videos. Then you'll want to create the form fields. So we're essentially just making it so that we're not using the prompts now. So we're making it so that the file field accepts movies and MP4 files. So it's only going to accept videos instead of any type of file. I'm creating some state fields here. This is mostly React code. It's mostly not Amplify code. So again, if you're new to React, you can use this with Angular. You can use it with Vue, vanilla JavaScript, iOS, Android, really up to you what you use with this. I just am most comfortable with React, so that's what I normally write my demos in. But you can imagine this code in a different framework or language even if you want. Making it so that those form fields handle change properly. And again, that order field was an integer, whereas the other ones were strings. And also making it so that you can upload a video using this form. We'll now create an onSubmit. I love using Emmet. That's what I'm using to make everything go a little bit snappier. So you can see that I'm using that whenever I do input:/submit or whatever. Okay, we're going back to copy and paste driven development where we're copying this code to create a new file. And we're going to use the state fields instead of these hard-coded ones. I'm going to skip ahead a little bit here. So the next thing that I'm going to do is go to the command line. So this is the completed video for code, but I'm going to do Amplify add storage. And then I'm going to use content, and I'll add authentication if I need to. I already did in this demo. So then we'll add different roles for different people. So authenticated users can create, update, read, and guest users in this case will be able to do everything as well. But in a real app, you'd want to probably make it so that only authenticated users can upload things or even delete things as well. So then we'll implement storage from AWS Amplify, and we'll await storage.put. So this will allow us to put the video in that S3 bucket. I'm going to skip ahead again, but this is going to make it so that all the videos show up on the page. You're querying for all the different videos right here. So that's storage.get. This is the Amplify libraries, and these allow you to connect your backend resources to your front-end resources. I think it's also important to note that you don't need to use Amplify for everything. You can use it as you need it. So Amplify also has static site hosting. So if you want to just use that, you can do that. If you have an S3 bucket that you already provisioned and you want to demonstrate those or display them on the page, you can do that using the Amplify libraries. So you can use all of these things independently of one another and as you need them. So again, now the videos are displayed on the page. So if you want to learn more, you can go to the documentation docs.amplify.aws. I am A Spittel. You can ask me questions if you want via social media, or my YouTube again is Ali Spittel Dev. Also want to shout out that we're hiring. So if you want to work on this every day like I do, you can reach out about those as well. And thank you so much. I'm going to transition into questions now. So if you have any of those, put them in the chat. I'd love to see them. Okay, so I am seeing some questions about first, why it's used indexed DB, and why that's used. So it's not actually like called local storage on mobile. It's the whatever the default local file storage is on those. I'm just not a mobile developer, so I'm not as well versed with talking through those things. And what positions are you hiring for? So I'm specifically hiring for my team an Android and Flutter developer advocate. So if you're an Android or a Flutter developer advocate, I would love to talk to you, but they're also hiring all sorts of engineers at different levels. There's also a developer support manager. So if you like GitHub issues and things like that, then that might be a good role for you. But if you're interested, reach out to me. I also got a question about what the pricing is like. And so there is first the free version. So you can use Amplify without even having an AWS account. You can test this all locally on your own machine, only using the local storage instead of anything on the cloud. So that has no charges associated with it. And then under the hood, it amplifies all these other AWS services. So most of them do have a free tier. So you can store a certain amount of data for the first year for no cost. And so you have to look into those individual services. Each one's going to be a little bit different. Cool. I think I got through the questions. That's pretty exciting. But thank you all again for coming. This has been a lot of fun.
Thank you very much, Ali. Yes, you managed to go through all the questions. That's great. Actually, we have Viba Abir who says that he really loves your podcast, your Ladybug Group podcast.
Thank you so much.
And yeah, so thank you very much for coming and showing us the power of Amplify. And yeah, enjoy the rest of your day. Thank you.
Thank you so much.
Bye-bye.
Bye.
For our last talk for today, we have Tanner with us, who is the creator of many React libraries, which one of them is React Query. If you don't know React Query, this is a great chance for you to get started and to try it out. I use it for my projects. It's a great library. And without further ado, please welcome Tanner on stage.
Hello, everyone.
Hey.
I hope you can hear me okay, and I hope everything looks good. I'm broadcasting from the beautiful Oregon coast in my car on vacation, and what a wonderful time to be alive.
Wow. Yeah.
So,
thank you for dedicating the time on your vacation, and if you can just share your screen.
Absolutely. My Wi-Fi went out this morning, so I had to go on the hunt for some Wi-Fi. It's been fun though, but yeah, let's get into it.
Yeah,
let me share my screen here, and we'll get going. Can you see?
Here is your screen, and yeah, good luck.
All right, thank you. Let's go. Okay, so just to make sure you can see my screen still.
Yeah, we can.
Awesome, thanks. Okay, well, I come from a company called Nozzle. I started Nozzle with a couple of friends about 7 years ago, and I'm currently the co-founder and VP of UX UI there, and it's been a blast. We reverse engineer Google to provide search rankings and rankings analytics data to basically anybody who wants it. It's really useful information, yeah, we love providing that. Recently, I've been doing a lot of work on TanStack as well, which is just kind of the open source collection of all my tools for writing software in React and JavaScript. And yeah, part of the TanStack is what I'll be talking about today, which is React Query. And React Query is an awesome tool that I never thought would be where it is today, but apparently it's extremely useful. React Query has grown in like significant popularity over the last year or two. It's just crazy how much it's grown, and it's just going to probably keep growing. I'm so happy to know that people like it and that they're using it. So thank you to everybody who is using it. People who are hosting this podcast and lots of companies, lots of people are using it. It's primarily it is a data synchronization library. So it's in charge of fetching, caching, and updating your data. It's important to make the distinction, though, that React Query isn't a fetching library like Axios or the Fetch API. It's more of a coordinator of those libraries. So you can fetch with whatever you want. It doesn't matter if you're using REST, GraphQL. It could really be anything that's promise-based. In fact, there's even some ways to get around. I mean, anything can be a promise if you try hard enough, right? So it just uses promise-based stuff to fetch data for you, and it coordinates everything for you. So it uses a stale while revalidate approach, which essentially just means that you're seeing cached data when you use React Query. And behind the scenes, when it's convenient, it's doing background updates based on a lot of different inputs from the user and you, the developer, and through configuration to update that information. So by using just a really small snippet, we're going to create a query. Use query is one of the hooks that React Query exports. You give it a unique key like posts, and then a fetcher function, fetch posts. And fetch posts just has to return a promise that returns your data, or it can reject or throw an error if you want. And by using just that small snippet, just out of the box, you get fetching and caching, background updates, and automatic garbage collection for your data all throughout your app, globally through your application. It's fantastic. So that means that all through your application, you can use different queries all throughout your application. Everywhere you write, everywhere you need data in your app, you can just write use query, or better yet, a custom hook that uses use query. And all of those data requirements and resulting network requests are going to get deduplicated and flattened, and it's all going to be optimized for you with zero extra work. There's a lot of other things that React Query can do. Request cancellation is a great one. It has amazing SSR support. The story behind that is great. We have experimental offline caching as well for, I know people are using it to store in local storage and session storage. I'm doing that. There's also people who have written offline storage utilities for React Native. There's great support for things like selectors. You can do polling. I'll show you guys some prefetching code here in a bit. Data lagging, which is an interesting concept I'll probably have to explain. It has infinite scrolling support, and it even has suspense support. Obviously, there's still some polish to happen around suspense and concurrent mode. Well, it's not concurrent mode, the concurrent features of the next version of React. So we're going to talk about all these things today, hopefully, and give you a good feel for how React Query works and how it can make your lives easier. So it also has dev tools built into it. The React Query dev tools are super advanced. They're just it's just a component that you render in your application. hooks up to React Query and shows you all of your queries. You can investigate them and look at what data they have and perform some very basic operations on them. Very useful. Really cool to see visually how your data is being fetched and deduplicated. So without further ado, let's code. Get some code done. Just gonna get rid of that here, and well, let's just jump into no better place to jump into than the documentation to begin with. So React Query, it's react-query.tanstack.com, and you'll find everything here that you'll need to learn and use React Query. It's used by a lot of people in production. A lot of companies you probably know and love, or maybe don't love. And it's used by a lot of indie developers too. People who are starting fresh in the React ecosystem are using React Query. And companies who have been around for many, many years are adopting React Query because of the wonderful benefits that it has. There is a course that I have on React Query. I will talk to you about that at the end here. Thanks to our sponsors on the Tan Stack for making all this stuff possible. And finally, we can jump into the code. This is kind of a bad view, so I'm just going to jump into the actual code sandbox here.
Tanner, I think we lost your screen. Can you try and share your screen again?
Sure thing.
I mean, we see your mouse, but we can't see the slides.
Oh, I wonder if it's a permissions thing going on. Sometimes that happens. Can you see the website?
Now we can see it. Yeah, we can see the website.
Cool. Well, I'm not going to rehash all that. This is the website, and it's pretty basic. Can you see this code sandbox right here?
Yeah. Mm-hmm.
Perfect. That's all I really need. So let's actually go back to this basic example. Let's see. Simple. The simple example is the one I want to show you because it's the easiest one to just kind of boil down exactly what's happening. So to use React Query, the bare minimum is you just need to import the query client provider, and the use query hook. And we use a provider not because we're using React context to fetch data and all this kind of stuff. We use context so that you can opt into certain features for certain subtrees in React. We use it to provide the client to all of the hooks that use it. But essentially just wrap your application in the query client provider with a query client that you just create right here. So new query client, drop in your client right here. And then you can start just rendering your application as normal. So here's a little example component where we have taken, you know what, I'm just going to simplify this. Let's just call this query. And I'll kind of rewrite this for you the way that I think it should be written. So use query. We call our hook inside of our component. We're just going to give this unique query just a string key, repo data. In reality, all of the keys are really arrays, but we make an exception for single string keys, so you don't have to use an array. So we'll just call it repo data, and then you pass your fetcher function. And I'm just going to use the fetch API right here. I'll make this a little bit bigger so everybody can see. This fetch API, everybody should be relatively familiar with it. We're just going to fetch some stats from the GitHub API right here for React Query. When we get those, we're going to turn them into JSON, and this returns a promise right here that should return our data. And it puts it all into this query object. And then from here, we just need to handle, we're not using suspense in this example, so we just need to handle a couple of scenarios. So if the query is loading, then we're going to return just a loading string. If the query has an error, we are going to show that error. And then we're just going to replace all this just with query.data. And query is fetching, which I will explain in just a second. So if we reload the page, it actually might be a little too fast to see the loading. We'll see my LTE here is actually really good. Yeah, didn't even see the loading state there. I wonder if we could trigger it. Let's see. Invalidate. Refetch. Nope. It's just too fast. But you'd see the loading state right here. And then if there's an error, you'd get a little error string. And then we just can consume our query data as normal. So here's the name of the repo, the description of React Query, And we have a subscriber count, stargazers, forks. And then there's also this little query is fetching. This just means it's background updating. So there's a lot of different times throughout the life cycle of an application that React query will update in the background. So you can see as we refocus the window, that's one of the events that will cause React query to refetch in the background. And every time it does, we can use isFetching to hopefully not show just like updating ... but actually show like a loading spinner somewhere that's kind of like, hey, we're background updating. And then you can see I've just rendered the React Query DevTools component right here at the bottom as well. And it just comes with this handy open close button. So this is all you need to start using React Query. And obviously, there's a lot more to it. So let's jump in now to a more, let's see, the basic example. It's going to give us a little bit more of a complex scenario. So here we have kind of like a blog post. It's like a fake blog. We've got some blog posts here that we can click on. And I'll just open the DevTools right here. You can see that we have requested the list of posts here. And if we inspect these, you can see we have the individual posts right here. But it's not the whole post. It's just the title. And when we click on one of these blog posts, it's going to fetch the actual post. So that's post with the ID of 1 right there. And you get to see the loading state a little bit better in this one. I'll click on another one. That loading state's really quick still. But we're getting the background updating thing too when we refocus the window. So this is the cool thing. React Query is automatically caching for you. So anything that you've already loaded, if you come and click on that again, it's going to be instant. It still fetches in the background to make sure that the data is up to date, but you're going to instantly see what you've already cached, including this global post list. When we hit the back button, it's instant. And because it's instant, we also restore things like scroll restoration, which I don't know if it's going to work on Code Sandbox. Yeah, it doesn't really work on Code Sandbox, especially with the way we've set up the example. But it will handle scroll restoration in your regular applications, especially if you're using just a tool like React Router. So it's not too difficult to do this either. We just have a use posts hook that's giving us our main post list. And we're loading that right here, kind of doing the same thing we did before, status checking and looping over the post items and rendering them, making a little link here. And then we have the individual get post by ID function that here's the use query for that. This is the interesting one where if you look at the React DevTools, you can see that all the keys for React Query are arrays. And you can use that array to be distinct about the data that you're fetching. So here we're fetching a post, and then we can pass the post ID to make that request distinct across all of our queries. And that's how React Query identifies your data, is by this key. So we're taking the post ID, and as we click on these different posts, you can see it's kind of caching and keeping tabs on all these queries that we have already fetched. And we're just doing that with one hook, use post with post ID. And we have a use query statement in here with that post ID. So pretty handy, pretty cool. Again, we're just checking statuses here and rendering the data when we get it. Nothing too tricky happening yet. But let's move on to a different example. So this one is using GraphQL requests instead of fetch. So it's always fun to show people that GraphQL can be used as well. Same thing, we're just giving it a key, and then we're using the GraphQL request with our endpoint and querying the data that we want. It's really nothing different except for that fetcher function. So it's all basically the same benefits. Let's move on to this one. Let's refresh this page. So this example is, I guess we got to refresh the browser. This example is an optimistic update example that shows you that You can also do mutations with React Query. So we have a use mutation hook here. It's a really simple hook under the hood. And this use mutation hook allows you to create mutation functions. So right here we have use mutation, and we're passing it a mutation function, which is basically just, it basically takes whatever object or variable that you want, and then you call a function that returns a promise, and this function is going to mutate something on your server. It could be a deletion, an update, a creation, whatever. And right in here, we're just posting to this data endpoint. And it has some hooks that let you do some interesting things. So what we do is we say on mutate. Of course, there's a car alarm going off behind me. That's typical. This on mutate function, this callback will get called when we call our mutation, but before this function runs. And so what we're able to do is actually optimistically update our query cache with what we think the server is going to have. So let me just create some things here. I'm just going to type A, B, C, D. As soon as I hit the enter button on those, they're getting added to the list immediately. But it's not until they come back from the server that they're getting capitalized. So E, F, G. And you'll see that the F actually ended up not coming back in one of the requests. And that's because the create request to create the F item, it failed on the back end. And React Query also has an on error handler for these mutations. And what you can do is you can keep track of the previous value through this on mutate function. So you can say if something happens on the server that this mutation would fail, we can roll back to the previous value. It's extremely useful. And on settled, we can basically say whether there was an error or it was a success, we just want to invalidate our to-dos query to make sure that all of these items just get refetched anyway. And so I'll do that one more time. Let's see. Hold on. TS of undefined. Okay. A, B, C, D, E. And see, we had an error somewhere, probably on B. So it rolled back and then revalidated. So React Query is always keeping your mutations and your queries in sync. It's really cool. This little example is for pagination. I think Code Sandbox doesn't like that I have so many of them open, so I'm going to close some of these. This is a pagination example, and this is a fun example because usually this is something that you wouldn't be able to do unless you were using something like suspense. Essentially what it is you've all encountered this before, where you have a page of items, and when you click next page, when you click that next page button, they all disappear and you see a loading icon until the next one loads. But with React Query, you're not seeing any of that. In fact, we're kind of cheating a little bit here because we're prefetching. So I'm just going to turn off the prefetch. We can get a little more of a real example here. This is just with using the keep previous data flag. And keep previous data is so useful. You can use it for searching or pagination, but basically anytime that the user is going to do something that changes the variables of your query, and you want to keep the old data around while you perform the new query. That's what's happening. So we're going to hit next page, and it keeps the old stuff around until the new one comes in. Next page, old stuff around. You can see the current page is actually changing. So our state is updating to page 4, and then the new stuff comes in. And that is using the keep previous data flag here. And it works for searches too. So anytime that there is a new query going out, it will keep that around. It works even better if we turn on this prefetching right here. We just use React use effect and say, hey, anytime that a page loads, if there's more pages, then we're going to use the query client directly to prefetch the next page. And we just use our key system, increase the page, and then call fetch projects with the next page. And this is a really nice experience, because usually they can't even get to the next page before it's already loaded. So it loads that page. Well, I guess I need to save it and then refresh. There we go. So I'm hitting next page and it's like instant. I mean, it's immediately prefetching the next one as soon as I hit next page, but it feels instant because it's prefetching the next one just as I go. Really cool and really easy to do with React Query. This next one is an infinite scrolling example, and I'm just using an intersection observer here, and React Query has an infinite query hook where you can incrementally load on more items to the end or the beginning. You can actually go in both directions. So we'll just scroll down here and you'll see we'll hit, I think it's giving me one of those weird things again. Here we go. We'll scroll down. Oh, come on. This was working right before I came on here. There we go. As we scroll down, you can see that it hits that button. That button gets intersected by the bottom of the screen. And I wonder if my screen is just too short or something like that. Probably a problem with my intersection observer. But we can even load older versions here as well, which is interesting. So why on earth is it doing that? There we go. So here I'll just demo kind of the going in reverse, so we can actually load older items and tack them onto the end. You can see these are negatives. And when we get down here to the bottom, it should load more posts. Load more posts. And that's the end of the list, so it doesn't load anymore. If we come look at our projects query, it's really cool because you can see the data for this query is in separate pages. So here's all of our pages, right? And the parameters that were fetched with each page. So this first page right here is the one for -10. You get the next ID and previous ID. Really cool stuff. It's really easy to do. Infinite scrolled pagination with React Query. Really nice. Just one or two more examples here. Let's see. This one is just a quick demo of how you can use a hover event on links to prefetch the next query. So down here in our list of Rick and Morty characters, when we have an on mouse enter event that happens on one of these items, we fetch the character where that link would actually take us. So I'm just gonna hover over some of these, and you can see they just prefetch and get bold. And so by the time we click on them, they're just instant. So all of these are now in the cache. It's actually kind of fun to do this with the query cache open. So you can see as I scroll down the page, they all kind of get prefetched. And then as I click on them, they become active and refetch in the background. Really, really fun stuff. Yeah, I think that's kind of all I wanted to show today on React Query. There's a lot of information out there on React Query. Another great resource for React Query is TK Dodo, or Dominique's blog. Dominique's had been helping me maintain React Query for a while now, so everybody should go on Twitter and personally thank him for his hard work. But he has some really great blog posts about React Query and just phenomenal information about taking it to the next level. So definitely start with the documentation for React Query. It's very thorough, talks about low-level concepts. It's more of a guide-based experience. There is also just kind of a general API here at the bottom that you can check every individual exported utility. And then if you want to take it even further, I have a course called React Query Essentials. And you can take this course. It's only 3 hours long. And basically, I impart to you all of the React Query wisdom that I have. as fast as humanly possible, and so you can kind of get started going really quickly. So there's essentials, there's the documentation site. Why don't we really quickly, before I wrap things up, I'll just kind of throw out some new things I've been working on. React Charts is something that is going to be coming out very soon. It's in beta right now. If you do any kind of charting, or you've always wanted to do kind of any type of charting, you should go check out React Charts. It's probably one of the easiest libraries to use ever. Might be even easier than using React Query. We'll see. But it comes with great features, and there's a ton of data visualization options inside of here. Also, React Table, new version coming up here soon, all written in TypeScript. Same with React Charts, the new version's all TypeScript. You can kind of stay up to date if you go to tanstack.com and sign up for the newsletter. You can check out some of the links here. Thanks to the sponsors, again, who sponsor Tanstack. These guys get awesome perks and get to rep their company here on tanstack.com. And let's just head back to whatever I had left here. I'm trying to remember the essentials course. And oh yeah, we have a Discord server for Tanstack. Scan this QR code and join the Discord server. We are having awesome discussions there all the time about everything, React in general, but also specifically the Tanstack open source tools and stuff like that. This is where you can find me, just at Tanner Linsley everywhere. Make sure to visit nozzle.io and see what we're all about. And yeah, that's it. So there's Dominic's profile. Everybody should go follow him because he's great.
Thank you very much, Tanner. Actually, we have a few questions from the audience.
Yeah, for sure.
So just 1 second. Okay. So what are the main differences between React Query and SWR?
You know, that is a great question, and I am going to share my screen one more time. So if you go to React Query and go to the documentation, there is a comparison chart right here with comparisons to some other tools. There's React Query, SWR, Apollo Client, and RTK Query. The RTK Query might not be up to date. We gotta work on that one a bit. But you can see some of the direct comparisons here. So SWR is half the size, but we're still talking only 11 kilobytes for React Query. SWR uses some different strategies for comparing data across renders for query key changes. It does some different memoization things. We do a lot of structural sharing in React Query, which helps you avoid a lot of unnecessary re-renders. We have built-in first-class dev tools, better support for infinite query directions. The lagged query data is something that's very special that we have. Selectors, you're not going to get garbage collection with SWR. Mutation hooks, I think, are third-party at the best. There's no offline support, prefetching and cancellation, and kind of all of these quality of life features. Stale time configuration is a big one that SWR doesn't have. And stale time is a unique concept to React Query, but think of it almost like cache timeouts for how long you want to keep your data fresh in React Query. You can configure all of that. You can configure everything in React Query, but you can't really do a whole lot of that with SWR. And other tools do some of that. RTK Query is pretty good, but kind of the Apollo Client and SWR, in my opinion, are kind of lacking some of the quality of life features that I would expect out of a library like this. So that's my answer. Go check it out.
Actually, Dominique here is doing a great job answering all the questions on YouTube. He's here with us.
Just as I knew he would be. Man, great guy.
Yeah, so he's like nailing all the questions. So nothing left to for you. But actually, one of my favorite Tanstack libraries are React Virtual.
Yes, and I need to add that to the tanstack.com. React Virtual is a good one. It doesn't have a whole website or thing yet, but it should. React Virtual is an awesome utility. it's a hook for doing virtualized lists in React. It seriously is so good. In fact, if I can, I'm just going to share my screen one more time.
Yeah.
So let's show React Virtual off because it's fun. Let's see, React.
Actually, React Virtual powers our feed. So every time someone goes to daily.dev, they uses the React Virtual. Yeah.
Nice. Yeah, it's really easy to use. Here's a quick demo right here of how easy it is to use. So you just need to track the div that you're going, or whatever element it is you're going to scroll. It could be the div. There's support for the window element in there as well. And then you kind of just put how many items you have. So size 1,000 or 10,000. This is how many items you're going to have in your list. There's a size estimation function. So we're going to estimate that these items are 35 pixels tall. But it doesn't have to be exact. You can actually measure after the fact. And then it just gives you back a row virtualizer object. And with that row virtualizer object, you just use the total size to kind of artificially size the inner div. And then you use the virtual items that it gives you back. And those virtual rows have an index and their own pixel size and the start. So the offset, the Y offset or X offset. So you can use start for that. But you can use two React virtuals at the same time to do grid virtualization. It's really neat. Somewhere inside of here.
Yeah, I saw this demo. Yeah.
Oh, right here. So here's the dynamic stuff. So these are dynamically changing row sizes, which is really difficult to do. But you can see how fast we're scrolling here, and these rows could be any size. We have no idea how big these rows could be until they render. You can do, so there's the rows, here's the column view, here's the grid view. So we're kind of just moving around all, scroll to 5,000, scroll to 999. So really, really neat stuff for the virtualization. I'm glad you brought that up. Everyone should try that as well.
So here is another question, and with that we will wrap up. You mentioned server-side rendering at the beginning, so someone asked here, what about React query with Next.js?
Yeah, so there is a whole section in the documentation devoted to SSR and server-side rendering for React query. And React query, we like Next.js. Our best example is written in a Next.js container. So go check out the SSR and Next.js container example. It's on Code Sandbox and the documentation. And you can see exactly how it works, or you can go read the documentation to see how it works there as well. It doesn't have to be with Next. You can use anything you want. It could even work with Remix or Gatsby or who knows what. It'll work with anything, as it gives you the low-level utilities you need to set it up.
Mm-hmm. Okay, and also if you want to see React query in production, you can check out our GitHub repository as well, and see some of the examples. We use Next.js together with React query and React virtual with customized rows height. So yeah,
nice.
you have everything in one place if you want to see it in action.
Wow.
So thank you very much, Tanner, for all the work
pleasure.
you do and for this talk.
Yeah, my pleasure.
And enjoy the rest of your vacation.
I will. It's fantastic up here. So
thank you very much.
Yeah.
Bye-bye. Before we wrap up, another great event, fantastic event of the monthly dev, there is this epic prize that we are giving away. So on the last event, we announced that we are going to give Sonos One to one lucky winner who brought their friends to the daily.dev platform. So here is the winner for the Sonos One speakers. So this is Alison Neiret. So if you are here, congratulations, and if you are not, we will make sure to send you an email with all the details on how you can claim this prize. thank you very much for referring all your friends to our platform. And let's announce the next prize for the upcoming event on August. So if you can guess what is coming, so make sure to write it in the comments. And if not, it's coming in right now. So we are giving away Nintendo Switch for the lucky person who will invite enough people to our platform. So if you want to read the rules and start inviting friends, check out daily.dev/monthly-prize and get it going, and you will get your chance to win Nintendo Switch for free on the monthly dev episode. So hurry up, you don't have enough time, it's just 1 month. And yeah, thank you all for coming. I can't wait for the next event, and we will open the registration soon enough. We will announce it everywhere, so make sure to subscribe to YouTube, to our meetup group, so you will not miss any news from us. So thank you again, and see you next time. Bye-bye.